Okay, so this is the 21st century version. I don't imagine any of you are going to give me any gold right now. We have a recession on after all. This solution, this is actually an experiment you could do at home. I did do some trick photography there. Obviously, I paused the video. I tried to make it look like it came back as close as possible, but that actually takes a good bit longer than I was willing to wait. I didn't know if my camera battery would last sitting on pause for the hour or so it needs to go. So I did this yesterday. I made this copper. Let me see if I can get a piece of white paper. Hang on. Okay, so there maybe you can see the color a little bit better now. The copper on the right and the iron on the left. So, like I said, you could do this at home. My magic elixir is really not, in fact, magic. That'll blow your mind. And in fact, it's Miracle Grow plant food. Okay, so this is a better experiment. You can't read that, can you? My lighting is not great. Anyway, it's Miracle Grow plant food, and it contains a good bit of copper sulfate, which is why you get the blue color. When we do this in the lab, we actually use pure copper sulfate, and the copper is a bit better. There's a lot of stuff in the plant food, and some of the metals I think also react with the iron, and so this is a bit darker. This copper nail is a bit darker than it otherwise would be. Ordinarily, when you do this, you can get a nice shiny gold surface. So this reaction, I'm gonna give a link to another video done under better laboratory conditions, and the copper that plates out can actually be, look like really shiny copper. And it's simply a redox reaction where the iron and the copper trade electrons. So the copper has a higher affinity for the electrons than does other way around. No, right. Copper has a higher affinity for the electrons than the iron does. So we start with neutral iron atoms in the metal, and we have copper ions, that is positively charged copper, in solution. So the iron in the nail gives up 2 electrons to the copper in solution. The iron becomes iron 2+, the copper 2+ becomes copper 0, which is just copper metal. And so we call this a spontaneous redox reaction, where nature is trying to achieve its most stable point. So it's like water running downhill. The electrons are going to run from the iron to the copper. This is akin to electroplating, and you probably have heard of electroplating. You probably own electroplated material. If we supply a current here, we could actually make it go the other way. We could put copper metal in and push the electrons to the iron. Take the electrons from the iron to the copper by supplying an electric current. And when you do that, the surface that you get, so right now we just have copper on the surface of this nail. It's still mostly iron. When you do that, when you electroplate, the bond is much stronger, and you'd never be able to take the copper off of the iron. Here, if I rub this long enough, I could probably get the copper to come off. So, but this could be done in the 15th century, and no doubt was. This was no doubt observed by alchemists. Which gave them a hint. I have just turned a silver iron nail into a brown copper nail without chemical theory that came much later, late 19th century, early 20th century. There was no way to explain this. It was known, it was understood, people could take advantage of it, but they didn't really know what to make of it. And so in the first video, I hypothesized that an alchemist who observed this would have used it as a trick to try to lure gold out of unsuspecting drunk noblemen. I hope it worked for him. All right, thanks.